Hey, algebra students, this is your teacher, Ms. Hattabar. So the document camera is having all sorts of problems. So I've gone to a plan B and I've kind of jimmied the camera to point at the projector to show the notes to take for this weekend. So do your best to read them. I'm going to try to write really big so you guys can see it. But from here, I kind of, you can see the stuff that we're going to be going through behind me as I've recorded this like 4 times now. So we're going to see what we can do. Are you guys ready? Hopefully you have your notebooks out. I'm going to be over here, right here, but then I'm going to talk to you guys about stuff as we go through it. So, the lesson that we're learning about is 4.7, and it's all about equal formulas. So, as we start talking about more algebra formulas and how to move terms around, what happens is we can write things depending upon what variables we have, and then we can adjust our formula for that just by moving some terms around. So there's a couple of words to know. So we've got some WTKs, and with those WTKs we've got input, and input is going to be the x variable. So it's the number that goes in. It's the number that we put in that we get something out of. So it's the input value, and then we also have an output value. And the output value is also very important because it allows you to see what the results will be when you put something into your formula. So like we talk about like volume. If you put a radius in, what's the volume that comes out? If you put an area in, what's the volume that comes out? A lot of the times students will remember their in and out boxes. If you guys see this thing, you don't have to draw this in your notes, but let me move it up here so you guys can see it on the screen. So like a value goes in, that's your x, and then something happens, that equation, and then your y comes out. So you don't necessarily have to draw that, but just kind of remembering from elementary school is in and out boxes. How it looks like on a graph, you have ins and outs. So if you make a coordinate grid, the x value is your in and the y is your out. So if you need to pause the video to get this all copied down in your notebook, you may. Otherwise, you can keep on watching and rolling along with me. So that's the beginning of this lesson. So let's talk about some topics. I'm going to come back up here. And this is as far as I've gotten ever on this notes video here. I'm going to see if I can even zoom in a little bit. Ooh, look at this, you guys. We're getting good. We're getting camera good. Okay, so topics. What we're going to talk about is how to change something around. So in your textbook, we have a formula that takes Fahrenheit degrees, and it changes it into, it takes Celsius and changes into Fahrenheit. As you guys know, we have a lot of different temperature that we use around the world, and this one is, if I can get it written the right way, it is the Fahrenheit equals 9/5 of a Celsius plus a 32. That's supposed to be a 3. So if I wanted to find, if I had a Fahrenheit temperature and wanted to change to Celsius, we can easily make this adjustment now that we know some algebra. So hopefully you see some 2 terms here. And we want to solve for C. We want to get C by itself. So if you take a look, what do you think we should do first? You are absolutely correct. We're going to get rid of this 32. So now this side goes away. Over here, what we're left with is Fahrenheit minus 32 degrees equals 9/5 of Celsius. And we can solve for both of them this way, but let's make it even a little bit easier. Let's get rid of this 9/5 right here. If we can get rid of that 9/5, then it would just say Celsius equals this stuff. So how do we get rid of this 9/5? Well, can you think about what that might be? You're right, we multiply by the reciprocal, 5/9, because then we can 1 all this stuff, and then we get a Celsius on the side. But remember, in algebra, whatever we do to one side, we have to do the other side. So we're going to take that over here, and we're going to multiply by 5/9. So now we have 5/9 of Fahrenheit minus 32 degrees equals a Celsius. And as always, you can simplify a little bit further even by distributing out that 5/9. But because 32 is kind of a funky number, and it doesn't go with ninths very well, we're just going to leave it like that. So as you guys can see, we can now solve for Celsius. So up here, in this formula up top, we have Fahrenheit equals this, and down here we have Celsius equals this. So we can arrange formulas based upon what we need. It's a pretty sweet deal. A lot of the times what happens in math class, topic number two, is you're going to get a formula such as this, like 5x minus 2y equals 100. You might get a formula where it's all jimbled and jambled up and stuff is all over the place, and it'll say something like solve for y, or it'll say solve for x. Either way, so what's cool about this is if you can find that variable in the formula, here's my y right here, we're going to get rid of everything else but that y. We want to get y equals something. So we want to have y equaling some numbers over here. Okay, so if you take a look, how many terms do you see on the left side of your equation there? You're right, there's 2. So let's get rid of these 5x's. So if I get rid of 5x's, what I need to do is subtract 5x's. But what I do one side, I have to do the other side. So now I've got negative 2y equaling 100 minusing 5x. And to get 1y by itself, I think you guys hopefully know this one. We're just going to divide by negative 2. So y equals, oh, my favorite part. We get to love math. We're going to love both sides of my terms. And I'm going to have 100 divided by negative 2, which is, you are right, negative 50. And if I have a negative 5x divided by a negative 2, plus a 5 halves x. So I can write that as a fraction. Now I know some of you guys are decimal lovers, but as you know, I love my fractions, so we're just going to leave it like that. So that's pretty much it. That's what you're doing. You're going to solve for different variables. And see how it goes. And so it's a pretty sweet deal. You're just going to move variables around, move variables. Sometimes you might see variables. The last thing I want to show you, topic number 3, because this one always kind of throws students whenever they get to these homework problems. You may have something that looks like this, like volume equals length times width times height. And sometimes it'll be volume equals length, width, height all together. So remember, when variables are right next to each other, it just means to multiply them. So that means, oh, I'm sorry, here's your dot, you guys. I know I'm going to get yelled at for that on Monday. But when you just multiply things, so if you wanted to solve for, let's say that we were solving for the W. If you have the volume, the length, and the width, and you want to know what the volume, the length, and the height, and you want to know what the width would be, we can use our formula to solve for it. So here's my variable right here. If I had like a 3x and I wanted x by itself, you guys know to divide by 3. Well, if I have a w and I'm multiplying by an l and an h, what do you think I do? You're right. I divide by a length and a height. This way I can one out my length and one out my height. So over here, I'm also going to divide by a length times a height. So it's going to be volume divided by length times height equals the width. And that would be my formula for solving for w. Kind of a cool deal, but that's what you get to do. So have fun with your homework, yes, of taking all these notes, and we'll talk more about them on Monday when I see you guys again, or whenever your class is. All right, bye-bye.